All right, section 9.10, absolute value inequalities, kind of combining everything we've learned about inequalities and absolute values and putting them together. Okay, so let's jump in here and look to solve the absolute value inequalities. That's all we're going to be doing today. So, for any constant greater than 0, if the absolute value of x is less than the constant, then we need to make sure to just go ahead and write it as the, remember, because absolute values can have a plus and a minus because it's distance. Okay, we're just going to say that x can either be either one of those, just like what we did in the last sections. Okay, same thing as we have an expression of an absolute value with an absolute value that's less than a constant, then we can also express that as a negative c or a positive c. And the inequalities in A and B are also true if they go ahead and just use the less than without the equal sign. Okay. Note if the absolute value expression is isolated on one side of the inequality, we say the inequality isn't in standard form. Okay. We want to make sure the absolute values are by themselves, just like when we were solving them. Okay, just like when they would have the equal sign, we're not changing the rules. Okay, so continuing on, let's just kind of look at an example here. Solve the absolute value inequality and graph the solution set. Well, it says the absolute value of 6 can be less than or equal to 6. Well, what is that saying? It's saying, come in here with a pen, remember, x right here can also not just be this, okay, but it can also be the negative 6 as well, okay? Because look, if we have x sitting right here in the middle, that means we have a distance here of negative 6, okay? Sorry, I'm saying that wrong, not a distance of negative 6, but I want to say you do have a distance right here, so let's get rid of this right here, okay? But then we also have a distance here, okay, both of 6 because that's how far away they are from 0, so that's how come you can have this on both ways. Okay, let's continue on. Let's try another one here. Alright, so we have the absolute value of x plus 3 can be less than 2. Well, that also means if we rewrite this, okay, let me grab a pen here, we can rewrite this as the absolute value. Well, we can know that we can write this as x plus 3 is less than 2. But we also know that we can mirror that on the other side and put the negative 2 on this side. Okay, well then let's just solve for x just like we normally would. Come here and grab the red. Let's subtract 3 from both sides. Okay, simplify it down. We're going to be left with x in the middle. Well, we'll come over here first. We got x is less than what? Well, 2 minus 3 is going to be negative 1. And over here, we've got negative 2 minus 3, and that's going to be negative 5. Okay, so we're going to have x is greater than negative 5, but it's going to be less than negative 1. Well, remember, anything less than negative 1 is going to go to the left because it's like we're getting further in debt. Well, anything greater than a negative, well, that's getting closer to 0 because we're getting greater than, we're getting out of debt. So if we have to draw this, let's come in here. Notice that we don't have any lines, so these are going to be parentheses. So I can come in here and let's just put a 1, 0, negative 1, negative 2, negative 3, negative 4, and negative 5. Well, x is greater than, okay, so this is going to be open because not equal to negative 5. Let's go and do this in red. Okay, well then x is less than negative 1. Notice that is also going to be the open, so it's going to be right here. And so x can be any one of these values in between here. So notice that it say, no, it does not say write this in interval notation here. We could easily come in here and just go, okay, well, I've got 2 parentheses because that's what the graph is telling me, and they go from negative 5 to negative 1. That would be our, we'll just call that our interval notation there. So pretty straightforward there. Let's do some more examples here. Alright, here's a perfect example of one that is not in standard form, but you're going to notice it's going to just solve just exactly the same. So we're going to come in here. We have to get this absolute value alone. That does not mean distribute. Okay, so let me make sure to write this in here and put do not distribute. Okay, Absolute values are not parentheses. Okay, don't treat them the same. Okay, so to get rid of this, notice we have 3 times the absolute value of 2x minus 7. So let's rewrite that as, how about, let's divide off the 3 off both sides before we rewrite this. Well, notice here, the 3 is going to cancel. 5 divided by 3 is going to give me a 5. Okay, well now we can rewrite this as 2x minus 7 is less than, well, less than what? 5. But that also means it's going to be greater than negative 5. And then once again, we'll just solve this like we did the other one. Okay, come in here, and we're going to add 7 to both sides. Okay, and then we'll come in here and rewrite, and we get 2x is greater than, well, 5 plus 7 is going to give us 12. Okay, and then negative 5 plus 2 is, negative 5 plus 7 is going to give us 2. Well, then we can come here and divide off the 2. Okay, and double check my math real fast here. Okay, we got 12 here. We're going to have a positive there, so everything's looking good. This is going to cancel. This will actually reduce out to a 1. So we can come in here and write 1. Bring down our x. Bring down here, and then we got 6. So x is greater than 1, but less than 6. Notice we have, these are both going to be open. Okay, so if we wanted to graph this, come in here, and I'll just start at 0, 1, 2, 3, 4, 5, and 6. Okay, just like the last one, we'll have, we'll start here at 1. We've got a parenthesis here. We'll close it off at the 6. And your x value is going to be everything in between here. Okay, and we could also do the interval notation if we chose to. We can come in here, put our interval, put our 1, 6. And so that lets us know that x can be any one of those values between 1 and 6, but not including 1 or 6. It can get infinitely close, but never actually reach it. Okay, let's continue on. We've got a note coming up here. Okay, the expression x is greater than 3 or x is less than negative 3 cannot be combined into one inequality expression. The word or must separate the inequalities, since any number that satisfies one or the other is a solution to both the absolute values of quantities. There are no numbers that satisfy both. Basically what it's saying is, let's look up here. Okay, these right here are ands. Okay, if we saw these on a graph, let's come back down here. Remember, these are like the, this is why we kind of learned about sets beforehand. Okay, you're going to have some that do this. Sometimes we're looking for this. Okay, well, that's the and. Okay, but then sometimes there's going to be situations where we're not looking for intersections. Okay, that's where we're looking at now ors. We're looking at where are they not intersecting? Though they still work, where do they not intersect? You'll see these in the example, and it'll make perfect sense. So, for any constant greater than 0, if the absolute value of x is greater than 0, then x is less than negative c, or x is greater than c. And the same thing with the, continue on with that with the expressions on the inside. So let's take a look at an example that they did for us. Okay. If x is greater than or equal to 5, okay, well, notice we have x is greater than 5. Well, there that is right there. Simple. But notice, when we create the negative, we have to flip the sign. Well, then look at how that's going to be graphed. You have x is less than or equal to negative 5. That's going that direction. You have x is greater than or equal to 5. That's going that direction. Notice, so x cannot be anything in between here, but it can be satisfied up to negative 5 and up to 5, anything infinitely beyond either one of those. So let's do another example here. Okay, we got 4x minus 3, that's the absolute value, is greater than 2. Okay, how I do these? I usually just write them out twice. Okay, so come here and get a pen. Rewrite like this: 4x minus 3 is greater than 2. There's my positive one. Well, when I come over here, notice I'm going to write 4x minus 3. When I flip the sign, this guy automatically becomes a negative 2. And then I can solve from there. I can add 3 to both sides here and get 4x. Get rid of that. Is greater than 5. Okay, divide by 4. Okay, and I get x is greater than 5 over 4, or 1/4. Okay, sorry, 1 and 1/4. When we decide to graph this, it'll help to know that. We'll come over here and do the same thing again. I'm going to add 3 to both sides. Okay, when I keep going with that, I get 4x is less than, well, negative 2 plus 3 is going to give me a 1. Divide off the 4. And then I get x is less than 1. Oops. Then 1/4. Well, now we can graph this. Let's come over here. Let's make ourselves a graph. Notice, gotta be very intentional here. Notice that this symbol right here means that we're gonna have an open. Looks like I pulled a bunch of those today. Let's go make us a graph here. I've got 0, 1, 2. I'll come over here and put 0. You know, I don't really need any negatives, but I've got negative 1 and then negative 2. Okay, looking at this guy here, let's remember that that's going to be 1 and 1/4. Okay, where's that? It's saying x is greater than 1 and 1/4, but not including that. So 1 and 1/4, so there's 1, and then 1/4 is going to be right about here. So there is my 5/4, and he is going to be going in this direction infinitely, in the positive direction. Okay, well, notice here it says x is less than 1/4. Well, 1/4 is going to be right about here. Okay, and he is going to be going in the opposite direction. Okay, now when I plug in any number into one of these, okay, into here or from here, it's going to make sure that that statement is always true. But if for some reason I decide to plug in a number that's in between there, or even including one of these statements, then it's going to be false. All right, let's do one last one. Very simple one, just going to be really, I don't want you to think it's going to be hard to remember this one, but don't get this confused with the equal sign. Okay, so notice I've got the absolute value of 3x minus 8 is greater than negative 6. Well, okay, first off, this is not a no solution, because let's just think about what this is saying. What is an absolute value? Let me write this out. If I have the absolute value of negative x, well, what does that equal? It equals x. Well, what is this x? Well, that guy right there is positive, because distances are always positive. Well, if that's true, then no matter what happens inside here, no matter what, isn't it always going to be greater than a negative number? Okay, so no matter what number I decide to put in here, you can test it. Put any number you can think of. Get as large as you want. No matter how far, if I gave you this, negative 1 million, okay, is greater than negative 6, well, you might think, well, no, that's not true. But yeah, we'll think about what is the absolute value of negative 1 million? Well, is 1 million. And that's going to be greater than negative 6. So the answer to this one is literally going to be all numbers. Okay, no matter what we put in, and this is how you could represent that. That means right there, remember that all real numbers there. No matter what happens, you're always going to have an answer. So if you run into a situation where you have the greater than and there's a negative, all real numbers, and you're good to go. All right, let's do some Hawks examples.